Silicon carbon batteries are finally making their way into consumer devices, and this is actually changing a lot. You've probably come across some adverts from phone companies like Honor and Oppo where they're saying they're using silicon carbon batteries in their flagship phones. Now, these silicon carbon batteries are no different from the lithium ion batteries in how they work. The main difference is the anode. The lithium ion battery uses a graphite anode, while the silicon carbon battery uses a silicon carbon composite at the anode. Now, if you don't know how a battery works, lithium ions stored in the anode move to the cathode, which is usually made of lithium-based metal oxides, mostly lithium cobalt oxide. And when you use your device, the ions move from the anode to the cathode, producing the energy required for all components to function. Now, when you plug in your phone for charging, your charger's current forces the lithium ions in the cathode to move to the anode, and the overall characteristics of both lithium ion and silicon carbon batteries remain the same. So the graphite anode takes 6 carbon atoms in a graphite configuration to hold a single lithium ion, and this actually limits the overall energy density for lithium ion batteries. Now, silicon can hold 10 times more lithium ions per mass basis than graphites. Now, why is it not silicon alone? Because we're talking about silicon carbon batteries. Even if silicon holds 10 times more lithium ions, silicon anodes have a problem because silicon swells to approximately 300% when fully charged. This causes the material to crack or lose electrical contact and even degrade the battery quickly. So the carbon in silicon carbon batteries is usually in the form of graphite, and it's combined with silicon to create composite anodes like silicon carbon anodes. And this helps by buffering the expansion because it absorbs the swelling of silicon during charging, and it also maintains structural integrity so the electrode does not fall apart. It also has improved electrical conductivity because silicon alone is not a very good conductor of electricity. Now, we have used lithium ion batteries for a long time now, and what are some of the reasons that shows that they need replacement? So there's the rise of apps, network connections, and even larger screens in mobile phones. Like 5 years ago, if you had a flagship phone with 4,000 milliamperes of battery, it was enough to last you a full day. But then today, because of the need for more power, you need more power. And silicon carbon batteries are offering more power, and it doesn't make the phone become even bigger because they're slimmer. So also the lithium ion batteries, if you need to increase the capacity of the battery, you need to make the battery even bigger, and people don't want the thickness of their phones to increase again. So the silicon carbon batteries help by making the phone have more capacity but remain the same size or even slimmer. So some examples of phone using the silicon carbon batteries include the foldable phones like Honor Magic V5, Vivo X Fold 5, Oppo Find N5, phones like OnePlus 13, Honor Power, which boasts 8,000 mAh battery, and the Redmi Note 14 Pro Plus. There's definitely more. These are some of the examples that I have. Silicon carbon batteries are able to offer more battery capacity with the same size phones or even slimmer. Now, if you take the Samsung Galaxy Z Fold 7 and compare it to the Honor Magic V5, you can see that the battery for the Fold is 4400 mAh, and for the Honor Magic V5 is 6100 mAh for the China model. And if you actually check the dimensions, you can be able to see that it's actually even slimmer at 8.8 millimeters, and for the Galaxy Fold 7 is 8.9. That is so impressive. Now, it offers also faster charging because you can be able to see in the same comparison with the Samsung Galaxy Fold 7, the Galaxy Fold has 25 watts wired charging, and the Honor Magic V5 has 66 watts wired, and you can be able to see that the wireless for the Z Fold is 15 watts, and the wireless for Magic V5 is 50 watts, and reverse charging is also affected because Fold 7 has 4.5 watts and the Honor Magic has 5 watts. So generally, the silicon carbon batteries are able to charge faster and also keep the charge for longer time than the lithium batteries. As a result of the batteries being smaller and providing more power, the phone, as it's been manufactured, there is more space for things like bigger sensors or more cooling capabilities because there is more space. And the phone might be the same size, but the battery needed to match the same capacity is smaller, giving more space for production. Now, the silicon carbon battery brags more charging cycles than the lithium ion battery, and it can be charged for approximately 1500 cycles, which is also impressive. In accessories like watches, the silicon carbon batteries will come in handy because they are smaller devices, but now they'll be able to have more capacity than the ones they have right now once the silicon carbon batteries are implemented in those accessories. It doesn't lack its own drawbacks because the main drawback of silicon carbon batteries is the cost issue. It involves expensive equipment, and automatically the phones with the silicon carbon batteries may cost a bit more to produce than their predecessors. This is still early tech, and the long-term data on aging and real-world durability is so limited. And some early adopters have reported some mishaps with the technology, but it's still early, and maybe with time it's going to peak and be greater. I hope you found that educative, and I'd like to know what you think about the silicon carbon batteries in the comment section below. Thank you, and let's meet in my next video.